Good morning and welcome to MATLAB. I'm coming to you live from my living room, and this will begin our journey in distance learning. So what I've done for you today is I've prepared some PowerPoints that I'm going to share with you that are going to cover what we'll do in the class, how we're going to make this distance learning work, and also discuss Chapter 1. So let me turn this over now to the PowerPoints. Share screen. And let's put this up. It's in fact a snowy day this morning. It's actually March 17th when I'm doing this, and hardly had any snow this year, but today it's snowing out. All right, so Lecture 1, Introduction to MATLAB. This is the QAC 154 Working with MATLAB course, and the day this is for is March 25th, 2020, which would have been our first lecture. So let's just take a moment to overview the course. So the objectives of the course are to learn the basic programming skills. We want to learn how to read, write, and reason about simple programs. Some of you may already be programmers. Some of you, this may be your very first programming experience. We're hopefully going to make the class interesting for all groups. We're going to learn the mechanics of MATLAB, so both the syntax of writing and understanding programs written by others. And we're going to use programs to solve interesting problems. So being able to break problems down into the pieces and solve them with the tools that you have available should allow us to synthesize solutions by combining those different pieces together. I would also mention that MathWorks, that's the company that makes MATLAB, has an excellent website. So as a company that runs this rather than being open platform free software, they do actually have an outstanding website. They have many different resources available for you. They have many videos here, and so we may actually take some time to explore some of those at some point, and certainly I would encourage you to do so. Just go to mathworks.com and feel free to search through. They also have a lot of videos on YouTube as well. If you have a question about a certain thing, you can just search mathworks.com. They have a whole library of videos on the basics as well as many of the add-on toolboxes that you can get and use for MATLAB. So let's just talk about some of the resources and support you're going to have available. So the most important one, of course, is me, and we'll be discussing how to make this online virtual learning work. But basically, we are going to have lots of different resources and support available. So the office hours, which will become virtual office hours, won't be an actually 6:25 for you anyways. So we have Monday 8:30 to 10:30, which is the general office hours. And then you'll also have some office hours from 10:20 to 11:30, and Thursday from 4 to 5. And I'll also be available online when our class time would have been, which is Wednesday from 7 to 10. I would also mention that there are other things that are going to be useful resources for you. The Quantitative Analysis Center does have a tutoring center. It's not clear at the time of recording how exactly that's going to work, but I do believe that we're making an effort to have online tutoring continue, so we'll give you some updates on that. The other thing that I would mention that's an excellent resource is the Information Technology Services, the help desk. So as you're probably aware, you could just walk in and get help with your computing problems. So of course you can't walk in, but they are available online. I know that currently right now, as we're undergoing this transition, that it's staffed not only by students, but also by some of the more senior staff. This is not the place to ask for homework help, but if you have issues, say for example, in downloading and installing MATLAB, that would be the place to go. So you should be able to download and install it from the IT website, but if you're having issues with that, this is the place that you can go. And these were their posted hours as of the time I made these slides. Of course, I think that they're adding additional hours, but we're kind of in a wait and see kind of thing with what's happening there. So anyways, check out their website if you need help, and I'm sure that somebody will be able to get back to you. Okay, who is this course for? So as I mentioned, Some of you may have some background in programming before. Actually, a couple of you have been in my Python course, and I know that some others of you are quite far along in your computer science studies, and others of you are probably just starting out. So wherever you're at, we want to make this course interesting for you. So for the prerequisite skills, we don't assume that you know anything. So we're going to start from the beginning. So we expect that you have basic computer skills, such as how to run a program, how to open, edit, and save a document, but we don't necessarily expect you have any programming experience. If you do, you'll probably be able to go further and do more with the course. But certainly for those of you who are doing this for the very first time, we're going to make sure that there's something here for you as well. The course is appropriate for people who want to start working with MATLAB, apply programming in the sciences, humanities, arts, or wherever else you may want to use it. And I would point out that MATLAB does have an awful lot of toolboxes for many discipline-specific areas. I know that some people in physics are using this. I think that's Greg Voth, who's doing some kind of fluid dynamics, is using MATLAB. I know that they're starting to use it in some of the ideas classes as well. So there are many different things you can do with it. I've used it in some of my research when I was at MIT. So there's lots of different things that you can do with it. So you might want to learn MATLAB basics for a research project, so you'd be ready to do a discipline-specific application, and also gives you the opportunity for some hands-on experience with a project-based learning experience, which will be your final project, which we'll talk about shortly. This course is going to fulfill some requirements, and so if you just go to the West Maps page, you can find out this information. So it is able to be used to fulfill requirements for the biology, mathematics, and NS&B majors, as well as data analysis minor, education studies minor, integrated design, engineering, and applied science minor. That's the ideas. It can be used towards a number of certificates, so it's the certificate in applied data science, certificate in informatics and modeling, computational science and quantitative world modeling, integrative genomic sciences, and also for the CIS, the CIS program. So I put these things out because maybe you're in one of these, or maybe you weren't aware that this is going to fulfill these requirements, or maybe you've taken a couple of classes in these areas, and it might turn out that this class puts you in a very good place to complete one of these. You know, maybe you only need 1 or 2 more classes, and why not get as many accolades on your transcript as possible. So just something to think about, and it may be something you'd like to revisit at the end of the course if you enjoy learning about MATLAB and are interested in pursuing this in a deeper way. So just a few words about me. I'm Professor Kelly Thayer. I am in the College of Integrative Sciences, and I work across a variety of different departments. My research is in the chemistry department. I teach in computer science and also in the QAC. And I've also taught a handful of other things, such as over the years, I've taught some courses in quantum mechanics. I've taught some of the journal clubs and some of the CIS seminars as well. So a variety of different things. You never know exactly where you're going to see me pop up. So this semester right now, I'm currently teaching the Comp 112, 2 sections, and this class here. And I also run a research lab, as I mentioned. My areas of interest are in computational chemistry. So I usually ask students to share some fun facts with me. So I'm going to share a few fun facts with you. First of all, I'm in fact actually a graduate of Wesleyan University. I got my PhD in the MB&B department, working in the chemistry department. I used hidden Markov models to understand DNA structure and dynamics. I also have rescued 2 greyhounds so far, one of whom is sitting on the couch right in front of me right now. He may start barking or come over to visit and say hello. And if so, I'll introduce you to Max. That's this guy right over here. And I also have Priscilla. And in a former lifetime, I was a semi-professional violinist. So that was when I was out doing my postdoc out in Chicago. I used to play for Chicago Businessmen's Orchestra. So I'll be asking you to tell me some interesting things about you, little known facts. All right, so this is the textbook that we're going to be using, and I would definitely recommend that you get it. To facilitate our online learning, I'm just trying to keep things really simple, and so I'm just going to have all of your homework and exercise just taken right out of the book. It will be important that you have access to the book. You can get the hard copies from RJ Julia Bookstore, and they actually just sent out an email that they do have them in stock, but I know that they are going to send them back at some point. You can get the book on Amazon. You can also get it in hard copy. It's available in e-copy. I've also contacted the Wesleyan Library staff, and I've asked them to have a desk copy, a virtual desk copy, available for students. So at the time of recording, I haven't gotten that information back yet, but I'll certainly be passing that along to you as soon as I have any of that available for you. If you're having a hardship getting a hold of the book and none of those options are working out for you, please just contact me and we'll work something out. This is the author. Her name is Stormy Attaway, and she teaches at BU College of Engineering. Very nice lady. I contacted her with a few questions, and she was very nice and very helpful. We'll also be having a Moodle website. So our Moodle website is going to include where our central place for putting together all of our information about the course. This is where you'll find information such as the syllabus and the course calendar. You'll also find links to upload your homework, to upload your labs, and where you can also find your notices and so forth if we have anything of that nature. Yes, I'll also be posting the slides from the lectures here. So as you're listening to the recordings, if you want to follow along, you're welcome to do that. So as I'm sure you're all eminently aware, we're dealing with a situation where we have to do distance learning. And unfortunately, with this class being a fourth quarter, we haven't had the opportunity to actually meet with the vast majority of you. So I just want to take some time to talk to you about how distance learning might work and how you can reach out to me. I know that this is suboptimal in a lot of ways, but it's my hope that we can make the best of this situation and that you'll still be able to learn how to program in MATLAB and that we don't lose this time. So I've prepared a document, a little text file that you'll find on the Moodle website that discusses distance learning and contains all of the links you'll need in order to find our Zoom meetings online. But I'd just like to take you through a few of those points. So I'm just gonna talk to you about, how does this work? What are my policies on this? How do you find the online sessions? How do you even go to a Zoom conference? So hopefully this information will help you get started with that. But of course, if you have questions, all you need to do is just send me an email and I'll be happy to do what I can to help you with this and whatever else I can do for helping you with distance learning in general. So first of all, to join a conference, what you want to do is there'll be a designated link for that time. It's kind of like a phone number. You have to call the right phone number in order to get to the conference that you want to go to. So you have to use the link that matches to the conference that you want to go to. And so if it's not during the conference time, then the link won't work. I think you'll just see a blank screen or something. So you need to go during the time that it's scheduled. So the link has to match the conference that you wish to attend. Like I said, it's like a phone number. You have to dial to the correct meeting. So if you go at the right time, but you use the link, say, like for a Thayer Lab meeting during our MATLAB meeting, right, you're not going to be able to join. So you have to pick the one that goes to the thing that you want to go to. The ones that you should be mainly concerned with are going to be, of course, our MATLAB meeting time, as well as the general office hours. Those would be the two things that you would be attending. So that brings us to this. When should you join and what if you can't make the meeting? So first of all, if you can join us during the designated class time, then that's terrific. There's not going to be any online lectures or anything. The lectures are pre-recorded. As you see, you're probably watching this one right now. So you can do that at your convenience, but you should be doing it during the week that we would have had that lecture, preferably like Monday to Wednesday, beginning of the week, by Wednesday, or even do it during Wednesday. So it's not required that you join in on any of the online activities. And if you can't do it or you're not going to be penalized for that. However, think that it is a good idea that we do stay in constant contact, because it's a tough thing to learn, and it's really important that you're getting the support that you need to. So I will be available during the time that we normally would have had class. So technically that's 7:10 to 10 p.m. So I'll just log on at 7 and be available to 10. People can drop in, ask questions. You should have looked at the video, and also you should be working on your lab exercises, which we'll talk about shortly, and that would be an opportune time to ask questions about that. Let's see, if you cannot join, right? So also you can come by during the office hours. So we have the office times that I've mentioned in the previous slide. So you should be able to come at those times. Now, this is my policy, and this is what I do in my real office hours as well. If you need to speak to me and you cannot make the regular office hours, you are welcome to go to any of the office hours, but with the caveat that if somebody else who's in that time, so let's say you went to my to the office hours that are designated for, say, like a Comp 112, like say you log in during my Comp 112 lab time. If nobody there needs to ask me a question, I will be happy to see you. So it'll be the same with them. They'll be welcome to stop in when we have the MATLAB one, but you guys will get precedence during that time. So you're welcome to come by, but that's how that will work. Like I said, you're not going to be penalized for not joining conferences, but they really should be helpful for getting through the material, and inevitably some questions will come up. So I would encourage you to please join at least one online meeting session or something once per week. If you can't do that, it'd be great if you could just send me an email update once a week. So I'm asking you, can you please just be in contact with me besides just posting your assignments at least once a week? If I don't hear from you, say for example, I don't see any of your assignments posted for a week and I haven't heard anything from you, I'm gonna be checking in with you. So please take the initiative to contact me a minimum of once a week, just so that we know what's going on. I think this is especially important with this class because we haven't really had that time to establish that rapport that we would have had we been meeting throughout the rest of the semester, and I really just want to make sure that you get out of this class everything that you need. If you can't go to an online session, so I'm thinking about the labs in particular, so what we would have done is we would have done maybe about 45 minutes to an hour of a lecture. We would have taken a little break and then come back after that, and then we would have worked together on some laboratory exercises to practice what we had learned that week in the lecture. So since that obviously isn't going to work and we're going to have to move into the asynchronous learning mode, it would be helpful if you can join us at that time and be working on your lab at that time. But if you can't, please work on the assignments anyways. Just because you're not joining us does not excuse you from doing the work. You still need to do the work if you want to take the class. So what you should do is you should do the work. So what are the things you need to be doing for the work? We'll get to the section on class expectations, but basically there's going to be some laboratory exercises and there's going to be some homeworks. So what you need to do is when they're due, you need to post them onto the Moodle website. I'll be putting up some of those little hand-in folder, those little hands, you know, they go like this and you put your assignment there. I'm sure you're familiar with that from your other classes. So you should be posting your solutions up there at the time that they're due. So in general, I'm trying to keep things as normal as possible. So basically the homeworks would have been due on Wednesday morning because I have time to grade them and look at them and give you comments on Wednesday morning before we meet. And then you would be doing the labs during that 7 to 10 period on Wednesday. And then I would have been giving you comments on them for Thursday. So I'm going to have the times that they're due consistent with that. Now, if you have a serious problem with that, or you're in a different time zone and you need, like, 2 extra hours or whatever, please just make me aware of your situation. We're going to try to be as flexible as possible, but if you can do it on time, that would be very helpful. You're also going to have a course assistant, a TA. So my research student, he's a BAMA, Kendar Sarandag, has agreed to work with you in your MATLAB. So he will be holding some Zoom conference times for the TA hours. Those hours are TBA at the moment, but we'll be working with him to do that. He's a great guy. He's very knowledgeable. He's taken a lot of QAC courses. He's an expert in R and many other things, and he also does great research with me, which involves a lot of working on the computer. So I think you'll find him to be a very pleasant person and also just very knowledgeable. So he should be able to help you out quite a bit. They will likely be in Eastern Standard Time, evening hours, but I am going to be asking you to let me know what the most convenient times are for you so that we can be sure that everybody has the opportunity to get help. Like I said, if you can't make any of the office hours and you can't go to some of the other designated hours, you should be in email contact with me. The other reason you should be in email contact with me is if, for example, you need to speak with me and none of the times work, or you have a personal matter that you would feel uncomfortable raising during a session, like an online session, because other people may be logged in and could possibly overhear the conversation. So this would be, you know, if you have a concern about your grades or that kind of thing. Or maybe you have accommodation letter or something like that that you wish to discuss, not in front of other people. And that's perfectly fine. Just send me an email and we'll either cover it through email or we'll arrange for a one-on-one meeting. If there happens to be an excessive line of individual questions to discuss, like this sometimes happens around exam time, I do reserve the right to impose a 10-minute limit per person, topic, and or question, just so that we get through all the topics and questions and get to everybody so that they can ask what it is they need to ask. I also have a policy that I am not going to record online Zoom sessions unless I clearly notify you that I'm going to do this. So I generally am not planning to record any of the conferences because I think there are a lot of privacy reasons. I don't want students to feel uneasy about asking a question because others would see them do it or they'd be recorded asking the question. So my policy is I'm just not going to do it. And if for some reason I am going to do it, I will clearly mark the session like this is being recorded so that you'll know. But basically, I'm recording the lectures, and then when we have the Zoom conference times, I'm not recording that, and I would certainly expect that you're also going to have the same respect for your classmates and also not do that. I'm not even sure that participants can do that. I don't think so, but anyways, the expectation is that you wouldn't be recording those things without the permission of the people who are in the conference. So that brings me to the online meeting times. So our main time is right here, QAC 154, working with MATLAB. I'm keeping it to our regularly scheduled time. I realize this may be suboptimal for a number of you. Actually, technically, I think it's 7:10 instead of 7 o'clock. But anyways, I'm going to just be online from 7 to 10. This is the link you should use in order to join that conference. Like I said, you have to use the link that matches to the conference. So at Wednesday at 7 o'clock, you should put this URL link into your browser, and then you can join the conference if you are able to and want to do that. So if you want to go to some other time, then you can go to the general office hours. People who would be seeing me in the general office hours would include students who are in my other classes, so Comp 112, and then I have you guys, and I also have my research students. So anybody can see me during the general office hours. This time would be designated for you, and you would have priority during this time. I generally don't have a problem with students going to the office hours because, I mean, I have so many of them. It's usually just not an issue. But, you know, please just let me know if you are having a problem getting in. And like I said, if you can't go to those times, you're welcome to stop in during the 112. So this is my normal class time, so the 112. So they would have priority here, but you could certainly stop in and ask a question if you're unable to go to the other times, or, you know, you maybe just have something quick to ask. That's fine to drop by. Okay, so let's talk about the actual class itself and how we're going to do the grading. So as you might imagine, we have to have some modifications to what the expectations are and how this class is being taught in light of our current situation. So there will be a take-home exam, and when we get to the course calendar, I'll point out where that is, but it's basically the second to last week of classes, and it will cover the first 5 weeks in the class. It will be a take-home exam, as pretty much is necessitated by this. It will be open book, open notes, and so forth, and will be of the nature of just giving you a series of questions to answer. It'll probably be more problem-solving based, but there could be some multiple choice or that kind of thing. I haven't given a whole lot of thought to exactly the layout of the exam, but I will provide you with some more specifics as we get a little bit closer to that. So my plan is that I would post it on Monday and that you would have until Wednesday to complete it. So everybody should have an opportunity and there shouldn't be a bias for people who are in different time zones. I would expect that the exam would take you approximately 1 hour to complete, but because it is a take home, you can work on it for as long as you wish. We also have the laboratory session. So the lab, as I mentioned, would be an opportunity for you to practice. So what you'll be doing in the laboratory sessions is in your book, you'll be working through the practice problems that appear in the chapter. As you're doing your readings, which you should be doing prior to the Wednesday, and in this case, before you're listening to the videos, what you'll notice is there are some practice problems sprinkled throughout the chapter. There's usually about one per each of the major headings in each of the chapters. So we're talking about like 5 to 10 pretty short problems in there, and they will just take you through the basics, like an entry-level kind of question that you would have on solving a MATLAB problem. So what I would like you to do for the laboratory session is to simply work through those. Now we're going to learn how to make a MATLAB script, and so when we get to that in chapter 3, you should be moving towards putting your solutions in the script file. But until we get there, if you just work on it and copy and paste your work into, say, like a text document, it could be like a notepad document or a Microsoft Office document, copy and paste them out of your MATLAB, that's fine. And you can just post that to Moodle just as showing me that you've worked through those exercises. You also have homework, and that is going to be your MATLAB portfolio. The way that the portfolio works is that it should be a collection of materials where you have working problems where you showcase your ability to solve things using MATLAB. Now, we have people with a wide variety of backgrounds coming into this class. So what I'm going to do is I'm going to allow you to select which problems you would like to solve. And so part of what will go into the grading of your MATLAB portfolio is whether or not you've selected problems that are appropriate to your level. So, okay, if you come in and you're taking this class and you are like, you know, about to graduate senior CS major and you've done all the simplest, most introductory questions, like, I'm probably not going to give you an A+, okay? So there are going to be some more challenging questions towards the end and some simpler questions in the beginning. I should be more clear about that. So what we'll be doing is at the end of each chapter, there are exercises. And it's usually around 40 to 50 problems or so. I'm asking you to select 10 of those, any 10 that you want. But please select ones that are going to challenge you at the level that you're at. If you've never taken programming before, you probably need to work some extra drills. So you probably want to be working towards the beginning problems. Or maybe you're studying physics and you notice, like, oh, look, there's this really interesting physics problem that's, you know, in the 20s. Go for it. You know, please select things that are going to be interesting for you. So part of what we're doing here is we're building up a repertoire of problems that you know how to solve in MATLAB. And we'll be, of course, taking a look at those, helping you make sure you get it correct, because part of the reason why you might be taking the class is to use that information to solve problems that are of interest to you. If there are problems in the back of the book or in the exercises that are interesting to you, then those are the ones you should be working on. Okay, so what you'll be doing is you'll be selecting any of those 10 problems and working on them throughout the week. I'm asking you to please post them by Wednesday morning at 9:00 a.m. Eastern Time, because that is when I get out of my first meeting on Wednesday and I have some time to grade it. I prefer to grade on the topic that you've already done rather than grade after we've done a whole new topic that week. So it's great if I can just have those assignments and get that graded back to you on the next class day instead of leaving that for the following week, because we really don't have that many meetings together. Finally, you'll be doing a final project. And so in your final project, what you'll be doing is selecting a problem of interest to you. You might take this based on, say, for example, one of the problems that you picked up for an exercise, and maybe you just want to take it further. Maybe you're really interested in graphing data and you have a particular data set that you're interested in making graphs for. So that could be a project. Maybe you have some data analysis, so we'll be learning how to do for and while loops and flow control when we're writing some scripts. So perhaps something that you want to do is like have a data set and you want to parse that into different sets or do some kind of analysis on it. So that would be something else that you could do. So have a few things in mind as to what you might want to do. We'll be having a project proposal worksheet due in a couple of weeks, and I'll be talking to you about your ideas more as we get closer. That you'll need to complete for when your final exam would have been, which is going to be on May 13th during the final exams week. So that brings us to the course calendar. Here we see the overview of what will be happening this semester. Today we are on the course overview and intro to MATLAB. The other things we'll be doing is just moving through the first 5 chapters in your book. So vectors and matrices will be up next. This is a key chapter because MATLAB does in fact treat everything in the framework of vectors and matrices. This will help you brush up on your math if you haven't done vectors and matrices in a while, or if you haven't done them before, to give you the essentials you'll need to understand what's happening. Chapter 3 covers programming with MATLAB. So we'll learn how to make M files. The next one will be flow control using if statements. And finally, we'll be doing flow control using loops. So there'll be the corresponding labs to go along with these. It'll be done each week. I mentioned that you'll have a proposal to do on your final project, so we'll be talking about that and getting into that in this 4th week right here. And so you'll need to give me your ideas as to what you want to do for your final project. Your portfolios, this is basically our schedule on the homeworks. You can expect that there will be, you'll need to make a portfolio entry for each of the lectures that we have. So there'll be 5 entries at 10 problems each, meaning that you will solve a total of 50 problems throughout the semester. So you should consider that it's assigned on the Wednesday when we're meeting or meeting virtually or would have met. And then you should complete that. And like I said, if you can kindly get those in by 9 a.m. the following Wednesday, that would be much appreciated. And so we'll go through that. The exception is right here when we get to the take-home exam. So I'll be posting the exam on Monday and it'll be due Wednesday, April 29, 2020 at 10 p.m. Eastern Standard Time. This is when you would have had an in-class exam of about an hour, and then we were going to do some other lab activities. So what I've done instead is you just have that to work on. Now, so that you can focus on the exam, I'm not requiring you to turn in the solutions, so you'll have some extra time. So you can turn it in the following Wednesday, which is when we'll be having the final project workshop. During this time, it will be our opportunity to confer on what you're doing with your projects, how things are going, if you have any issues or questions, and also developing a specific plan for each of your projects to bring it to completion. If you're not joining us online, I would highly encourage you to have some kind of contact with me about your final project during this week. If I don't hear from you, I'll be reaching out to you via email to make sure things are going fine on your project. So please just be aware of that. Then the final projects will be due the following Wednesday, May 13th. So this is the time when your final exam in class would have been scheduled if we had one. So instead, your final project will be due then. So let us have a bird's eye view of what we're going to talk about today. So we've done the course overview. Certainly feel free to send me any questions that you have about that. I'd mentioned also you can see the course calendar document on Moodle, which is where you would find any updates to the class if we had any, although I don't expect to. And also the syllabus, excuse me, which basically explains those same things that we have been discussing right there. So you can see the course policies and you can see the breakdown of your grade again, but it's basically what I've just shown you now. So now we'll move into a first view of MATLAB and getting familiar with how to use it. The things we're going to talk about in this chapter are variables and variable assignment, So x equals 5 kinds of things you've probably seen before. How to do formatting, how to do operators and functions, and then constants and random numbers. MATLAB has a lot of these and is one of its strengths, so we'll take a look at what those are. So let's have a first look at MATLAB. So if you have issues getting it installed, what you should do is you need to contact the IT website or the help desk to get any assistance you may need to install it. It should be available off of the IT website. That's what they've told me that they've done, and they've made it available for you to download. I cannot download it because I'm faculty and they have a different license for me, so my procedure was quite different. So unfortunately, I may not be a lot of help in actually what that procedure entails, but they assure me that the help desk is ready and waiting to help you install MATLAB if you need to do so. Okay, so this is basically what is going to happen. You can double click on the icon. This is what your icon looks like. You can locate it in your start menu. If you're a Mac user, you can use Finder. And when you launch it, you will get this splash screen right here. And it takes a few moments to load. I would also mention, just getting back to installing the software, my install took about an hour and a half. So do plan accordingly. It's not something that's going to be done in 2 seconds. It's going to run for a while. Launching also takes a few minutes. It's not that long, but it's a big program. So when it does load up, this is what it's going to look like. So this is the main window right here. This is your command window where you're going to be typing your code and spending most of your time. This window is where your current folder is going to show. This is where all the files are going to be saved to unless you specify otherwise. And this is your workspace. This shows the value of the variables defined by the user. Now this area is also quite customizable, so I would mention that it's possible that yours doesn't look exactly like this, and it's also possible that you would be able to change it so that it looks different. So do feel free to do that, but anyways, hopefully this will just get you started in what it looks like and orient you to what you need to be doing. So you should be typing in this part right here. This is just showing you about the undocking of the windows. So each of these little sections, see how these sections are locked in here and they have these little down arrows like this. You can remove them and move them around. So this is showing you an example of that. Then they behave as independent windows that are all linked together as part of MATLAB. So use the arrow in the upper right corner of the windows, which is those little arrows right there. You can move it around. Workspace and current folder can be undocked. To redock, you use the arrows in the upper right and select dock. You can also customize the environment even more. So you see that we have this ability to maximize and minimize window panes using the arrow in the corner. So minimizing creates a tab. So you see that I have now a number of tabs over here and that the workspace is bigger. So if that's how you want to do things, you can do it like that. You can maximize to bring it back. Okay, in the environment group, so here's our environment group right here. Use the layout and then follow that to select layout to select a default layout of window panes. So if you play around with it and mess it up too much, that's how you can get back to default. In the environment section, use the layout show to select what windows are shown. So if, for example, you see different windows as compared to what's in the book, that could be why it's different. Mine was slightly different than what's shown in the MATLAB textbook. So, but I was able to discover that if I just changed the layout, that I could see the same thing. So pick layout show command history to make your view match that shown in the textbook, because they have this other command history in the book that is not shown in ours. There's also the tool strip and functional sections. So the tool strip contains 3 tabs, home, plots, and apps. That's this one up here that you'll find at the top of your window. The home tab contains a variety of functional sections. So that's what we're seeing down here. Each functional section group has buttons for similar tasks. So there, for example, here are all the working with files kinds of things, new, save, getting your scripts and so forth, right? And this is how you do Simulink, which is an advanced topic. This is formatting, resources, and so forth. Oops. Okay, the next thing we're going to talk about is variable assignment. So that is when we are going to have a variable and we're going to set it equal to something. So variable assignment assigns a value to a variable. The value can be expressed as an expression. Assignment operator. So this is going to assign a value to the variable. The symbol is equals. So none of this should be a particularly big surprise. So here's an example. Variable assignment. Also, as a note, the percent symbol is going to allow you to put comments in your code. So you can do percent and nothing will happen. This will become increasingly important as we move into working in the script files, but you can also comment these things. And then, for example, when you're going to copy and paste your work into, say, like another document, if I were to copy and paste it back in, then we would have all your comments in the percent symbols. Okay. Notice that equals is not the same as a mathematical equality. You should really think about it as takes the value of. So you're going to have a variable name equals an expression. Okay, so more about variable tables. So the variable table is going to report all the defined variables and the corresponding values that they have. So for example, this variable table here is going to be showing you that there are currently two variables that are in existence in this workspace. It's answer and my num. And their current values are 2 and 8. Those could be overwritten and changed simply by changing what it is. Here's an example of where we have a brand new command window and we set x equal to 5, and notice that over in the workspace over here, we now have the variable x, which has the value of 5, consistent with what was happening here. What's really nice about this is as your programs run, it will update the values here to show you what your current values are. If you've done looping before, you're aware that variables can have changing values as you're going through your program, and knowing what that is can be extremely helpful. So here we're showing that we could take it and we're going to update the value of the variable. So first it started out being equal to 5. Now what we're going to do is we're going to assign x is equal to 7. And it's going to say x equals 7 here, and it changes this to show you that it is 7. There's also a special variable called answer in MATLAB. What this is about is if you just simply have an expression that you evaluate and you didn't specifically assign it to a variable, it will automatically assign it to this answer variable. So pretty much you're always going to by default have ans, answer, for a variable. So here is an expression that is not assigned to any value. Notice that here is the expression, the thing that MATLAB needs to evaluate, and after that we have this percent string, which is not going to do anything because it's a comment. So it will continue to work, and it reports the answer, and that shows up over here in your workspace. So just like any other variable, when you update it, it's going to get overwritten and take on a new value. This is important to remember because if you are calculating something and you need to use that later on, then you shouldn't just store it in answer. You should actually put some variable name that you make up equals that expression, because otherwise it's going to just keep getting overwritten if you don't save it into something. So don't rely on answer to store your important information. You just need to know, like, what's the answer, 3 plus 3, then that's perfectly fine to do. But if you're going to expect to move on and do more calculations with it, you really need to give it a variable name. Initializing, incrementing, and decrementing variables. So initializing a variable creates the variable and assigns a value to it, as we have seen. Now, notice here that we have something very interesting. We have y equals y plus 1. This, of course, wouldn't make any sense in math, because you'd say, well, y cancels from both sides and we're left with 1, right? It doesn't make any sense. But that's why we're saying you need to think about get the value of. So how you should read this is the new value of y is going to be the current value of y plus 1. Of course, using a statement like this is going to require that you in fact have already assigned something to y. Otherwise, you'll be referring to a variable that has no value, and that will cause an error. So by incrementing a variable, that's when we add something to it, and we can also decrement a variable by subtracting something from it. Variable names have rules that have to be followed. So, for example, they have to begin with an alphabetic character. The name can contain letters, digits, and the underscore character. If you put a space in it, the problem is that MATLAB will think that it's now a new word, and it will try to think that it's a new variable. And most likely you'll end up getting errors. So please do not put spaces, use the underscore instead. Or use camel case, that is mixed upper and lower case to indicate your different words. Although underscore is allowed, it's not recommended because it can cause problems with some programs that interact with MATLAB. So we're generally going to avoid it in this class. So you should be using the upper and lower case so that it will have compatibility if you move on. Mixed case or camel case, which I'm showing you down here with the mixed uppercase and lowercase, is recommended for use with MATLAB. MATLAB is case sensitive, so upper and lowercase letters mean something different. Don't use MATLAB keywords as variable names. So bad things will happen. Names of built-in functions should not be used as variable names as well. Variable names should be mnemonic, that is, they should call to mind that which they stand for. So here is just some examples of the kinds of things that will and will not work. So you can't begin with a digit, and Python is going to give you an error, right? And here is some examples of some other alternates. So MATLAB is actually pretty smart and tries to make suggestions to you. So here, for example, is an alternate variable that you could use. You can see here by having two words that this is causing a problem. MATLAB is helping you to see that because it's showing you the rest of it in purple. So that's reserved for other functionality in MATLAB, and so it's parsing this incorrectly because you've put a space there. So when you start to see color change that didn't look normal, you should immediately wonder if you had a problem with your variables. And you'll see that it's also making a suggestion for you here. And here is some camel case, and so that is something that you could use. All right, numerical variable types. So a variety of types are going to determine the properties about the variable. You've probably, in fact, actually seen types before, but just weren't really actually aware of it. So for example, in math class, you've probably seen integers, and you've seen some decimal numbers and these kinds of things. So in MATLAB, we have the same thing. So there are different types associated with variables with the class, more in object-oriented programming when we start to talk about those things a little bit more later in the class. Numbers with decimal parts are represented with a floating point representation. The type that are associated with those are single and double, which are going to record numbers to shorter and longer number of decimal places. This basically is going to change the precision of the calculations that you do. Integers have several types, differing in the number of bits used to store the number. So examples are int 8, int 32, and int 64. Where this could come into play is if you're just, counting up to 10, int 8 is going to be fine. But if you need to count up to larger numbers, you may need to have more bits in order to store what the value of it is. This is in regard to the number of bits, so it's combinatoric. So it doesn't mean that you can only store 8, 32, and 64 numbers. It's the number of bits that are available. Unsigned integers record only the number and no sign, and also come in a variety of bit sizes. So these are the different options you have. And you can also ask MATLAB to explicitly tell you what variable type you have. So if you do workspace and arrow, and then you choose the column and you look at the class, it will in fact tell you. So this table right here is telling you that these are double precision values, which is the standard thing that MATLAB uses, which will be just fine for general purposes and should be fine for most everything in this class. There are also text-based variable types available in MATLAB. So the character type is char, which can be used to store two types of data, that is a single character or character vectors, which is a sequence of characters. These are enclosed in a single quote. Those of you who may be familiar with Python are probably accustomed to using the single and double quotes reasonably interchangeably. MATLAB is a little bit different and does treat them distinctly, so it's important that you note that difference. Strings can be used to store characters as a single entity, enclose those in double quotes. This is what's most similar to strings in Python, if you're familiar with that. You should use these when the character type needs to be iterable, because strings are not. They can be looped over to process each character at a time. This will become important when we discuss looping, which will be in the flow control sections, which will be chapters 4 and 5. If you need to process each item, choose the character, otherwise string will likely be the better choice. Here is an example of the report in a workspace to tell you that this one is string and this one is character. So Booleans are an example of relational expressions. That is, they're going to give back true or false, and we are going to use the operators greater than, less than, greater than or equal to, less than or equal to, the equality, or the not equal to. We also have the logical operators associated with this. We have or, and not. The type of the logical is used to store true or false values. So basically what's going to happen is the expression will be evaluated and then it will tell you true or false back. However, instead of actually telling you the words true or false, the way MATLAB expresses it to you is it will tell you logical, and it will either tell you 1 or 0. So the logical values 1 is true and 0 is false. Suppose you want to determine the type of a variable. So expressions are evaluated to a value that's stored in a variable, and by default, as we've seen, that's going to be the answer. The function class returns the class of a variable expression, which is essentially the same as its type. So here is what our syntax looks like. We have class and then the variable expression, and that will give you what it is. So here's a couple examples of how you can use class in order to figure out what it is. See how we're able to have it ask about a variable which has been evaluated to an expression, or you might also have, like, okay, so class of some expression directly, you're also able to do. Either way, you can figure out what it is. So suppose something is in one particular type and you want it to be in another one. Can you convert it to something else, or are you stuck with what you got? Lucky for us, we have typecasting. That is the ability to convert one type to another. Now, some things can be cast into another form and some things don't. So, for example, if you have cat, you can't turn cat into numbers because it's not numbers. But however, you could have some string of digits that you want to convert into a string. Now that would be possible to do because they would just be a string of characters. So when we do this, we're basically going to attempt to do it and then see what we're allowed to do. Also, we're going to mention about how the rounding is worked. So typecasting is to convert one type to another. Use casting functions. They have the same names as the target types, right? So if you want it to be an integer, you're going to be using int. So conversion to a variable by a type having more space may be desirable, right? So this would be, for example, converting int 8 to int 32 to give you more ability to store longer numbers, or you may want to convert a double precision to an int. You could use on strings to convert to ASCII numerical equivalent. So the way that this would work is you would use the casting function and the value. Just as a note, the way that this works is when I'm giving you a syntax examples, you do not type these angle brackets. The angle brackets are indicating you need to fill in something. And so here we would have a casting function's name, and then you would have the open parentheses, which you do type, but you don't type these angle brackets, and you would give a value. So here's a couple of examples over here. So here's value equals 6 plus 3, which of course is equal to 9. So now if we do class of value, we want to find out what its default type is. It will tell you double. Now we can also do that in a couple of different ways. We're going to reassignment with the casting into int 32, which has more space. And of course, it's still just 9. It doesn't change that. It's just its representation as it is stored on the disk is distinct. Then we do class value to check the type again, and we see that it's changed to int 32. Notice that rounding does apply So if we have x equals 3.6, and then we are going to here check on its type. We have int 8 with 4, and here we have z equals int 8 of pi, and we get only 3, right, because it's rounding. So next, let's talk about the formatting. So this pertains to how the view is in the window. There's long versus short, loose versus compact, and the use of the ellipsis. So for formatting, there is the default MATLAB, which is going to be to display numbers that have decimal points with 4 decimal places. The format command allows a particular output format to be used instead. Now that only just changes how it's displayed. It doesn't actually change how it's stored on the disk. So in the short format, 4 decimal places is default, which is probably going to be just fine for our uses. And the long format will have 15 decimal places, which you may need if you're doing more precise calculations, particularly working with small numbers. So what you would do is you would type format and the keyword. So here, for example, I did format short, and now we're going to do a calculation, and you see that we are seeing 4 decimal places. However, if we change to the long format as we're doing here, we see that we have a much longer decimal place. So that should be 15 places. More on formatting. The format command also accepts keywords pertaining to the compactness of the output in the command window. I find that the regular format is very annoying because quickly you fill up the entire space and you can't see your history. So you can do loose, which is double space is the default, which I personally don't like. Maybe you do like it. So if you wanted to change that, you could do compact, which will give you single space and it takes up less room, which is how most of the things that I'm copying and pasting into your PowerPoint have been done. So here's the format loose. You see how much space it takes up. But if we do it in compact, it's much closer together. The ellipsis is an operator that allows line continuation. So if you need to wrap something, use this when you have a long expression and wish to continue it on the next line. The symbol for the ellipsis operator is 3 or more periods. It's the ... So for example, you could have something and then an ellipsis and continue it. So here's a really long math expression and we ran out of space. So we did ... and it continues over on the next line. Operators and functions. So what are operators? Operators are something that do something to something. It's kind of like the equivalent of action verbs in the English language. They do something. You're probably already familiar with operators even if you haven't taken higher level math. So in fact, addition, subtraction, multiplication, and division are all operators. They do something. So when you see the plus sign, it means you take and you add the thing on the left and the thing on the right. We all know how to do that. There are more complicated operators than that. And if you've taken higher math, you're probably aware of functions as operators and operators that operate on functions and so forth. We don't need to get into all of that, but we do need to be aware that that MATLAB is working with this kind of operator idea in mind. So when you have something that is an operator, it's going to do something to something else. For example, if your operator is f of x equals x squared, right? It's going to take in an x and it's going to cause it to become squared and you'll get out the squared value. That's basically the idea. So unary operators are going to operate on a single operand. So you would have operator operand. So for example, -1 is going to be negation operator for operating on operand 1, right? So here is the operator, the minus sign. So this minus sign causes this operand, which is 1, to become negative. Binary operators are going to operate on 2 operands. That means basically you need 2 inputs. So you're going to have this syntax here, right? So you're going to have like 4 plus 5. So we have operand 1. Here's our operator plus, and the operand 2 is going to be 5. So it's going to add those 2 things together. Precedence rules, as you learned in basic math, are going to apply. So if you learned that mnemonic, please excuse my dear Aunt Sally, that's basically what it's going to be. So it's going to be the parentheses from inner to outer, exponents, negation, multiplication and division, left to right, whichever comes first, and addition, subtraction, left to right, whichever one comes first. I'd also mentioned that MATLAB does recognize scientific notation. However, it uses e to represent 10 to the raised to a power, which may be a little bit different and could be confusing if you're accustomed to using e to represent the natural logarithm. So this is an example of what this is going to look like. 2 times 10 to the 4th power is the exponential notation, and 2e to the 4, which is the scientific notation using e to represent the power, will also be the same thing. So let's talk about basics of functions. So a function operates on input, and most are going to return an output. We can call a function and it's going to execute the code associated with it. So for example, we have a function name and then we give it the argument. So as you can see, this is looking a little bit like operators. So here is the absolute value function. So MATLAB has a lot of built-in functions. That's one of its biggest strengths. The library of functions available, absolute value of -4. So the function is absolute value, and the thing that it operates on is its argument, which is -4. And so when absolute value operates on -4, the answer is 4. As I just mentioned, there are a number of built-in functions. Numerous built-in functions are going to be a great resource to you because there are many things that they can do and you don't have to program them up. There's also help in there, so we can't possibly cover every single function that's covered by MATLAB, and also just cataloging all the functions is really not a useful thing to do. So what you should do is you should look it up when you need to use it. The help function is going to be very useful for you in order to identify what resources are available that will be helpful to you. So for example, you can look at the getting started, or you could also view documentation using the help browser. Both of these things are excellent resources for you to refer to. Then once you identify a topic of interest, type help and its keyword to find out more. An example with elementary functions, L_fun, is shown to the right. So one thing that it does is it does organize them according to which section it's in. So they're stored by topic. For example, we have elementary math functions, and trigonometric is a group of them. So help and the function name will provide info on that specific function and links to more info. Help on the tan function is shown over here. There's also a number of built-in numerical functions. MATLAB has an array of functions already built in, as we've mentioned. Discovering the functions is easy. Using the help command to search the documentation. So what you want to do is type in what it is you want to do, and then MATLAB will try to help you find out which one it is, and then you should be able to identify which one it is by going in and reading the description of each one. Function are used with a basic unified syntax, allowing the user to quickly achieve complex calculations with high-level programming. MATLAB also has a variety of constants and the ability to generate random numbers. For example, constants are built-in variables that have unchanging values. You're probably familiar with some, such as pi. So pi is already programmed in and stored out to, it looks like, 15 decimal places here. So you don't need to type it in yourself, and you can refer to pi as a variable. We also have I, the imaginary number, which is equal to the square root of -1. You may have seen this if you've done complex numbers. This would come up in a pre-calculus class, for example, in taking roots of parabolas and these kinds of things. So this is going to give you a representation in the imaginary, in the complex number format, where this is the imaginary part over here. I and j are built in, and also j is equal to square root of -1 also. We also have INF for infinity, which is an arbitrarily large number. NaN is not a number, so for example, if you try to do division by 0, that comes out to not a number, so NaN is a built-in constant. Random numbers. MATLAB can produce pseudo-random numbers. It's actually not possible to truly generate random numbers, and no program, in fact, actually generates random numbers. So the best we can do is to have numbers that follow a distribution that matches to what a random numbers would make, and so we pull off of these distributions, and MATLAB is capable of doing that for you. So a process, in fact, actually does exist to determine the next number in the series. So usually they're working by doing things like pulling digits off of the calculation of pi or other irrational divisions. Other things that people typically do is use the sum of the dates. There's all different ways you can use in order to generate random numbers. It's not, in fact, all that important how they get generated, but in fact, just to recognize the fact that there is a process that exists, so they are in fact not actually random, but they'll behave as though they were random numbers taken from a random number distribution. Random numbers mean that they are uniformly distributed on an interval. So if numbers are truly random, think about selecting a random number from 1 to 10. What it means is that after many, many trials, it would be equally likely to pull any one of those digits. So it would be equally likely to draw a 2 as it would be a 9, for example. The seed is going to provide a starting point for the random number generator. So for example, you could imagine that if you're doing something that's based on the sum of the digits in the date, you need to start at some point. And so many of the random number generators are going to require a seed in order to get started. Then what you can do is you can see the random number generator with the number you just got, and so forth. For equal seeds, the sequence of numbers produced will be exactly the same. So if you want to get a different sequence of numbers, it's important that you change the seed to obtain a different sequence of numbers. So they should both have the same uniform distribution, that is, they should both be pulled off of a random number sequence, but if you need them to be different, then you want to be able to do that by giving them a different seed. If you want to reproduce a calculation and say you got an error and you may need to redo, like you'd never have a mistake, right? But suppose that happened, somebody else had a mistake and they wanted to do that. How could you do it? Well, so for repeatability purposes, that may be why you want to be able to control the input seed so that you could fix your mistake and move on. So RAND produces uniformly distributed numbers on the open interval from 0 to 1. So if you need to change that, what you can do is you can do shuffle. And if you need to change the values of which, so it goes from 0 to 1. Suppose you need it, in fact, from 0 to 10. What can you do? Well, what you can do is you can just multiply it. So then it will go over a bigger range. Suppose you need more than one decimal place. Well, what you could do is you could run the random number generator more than one time. So this is a little bit more on how to generate a random number on a specified interval. So what you can do is you can specify low and high, for example. This is the lower limit of the desired range and 5 is the upper limit. So here we have a formula. So if we did random times the high minus the low plus the low, that will give you a random number between your low and high interval. Okay, so this is how it's going to work. And there's a couple of examples of working that out down here, and you can see that we are in fact getting numbers between the range of 3 and 5. So you can change that to be whatever interval is of interest to you. So suppose you need to generate random integers. So the function rand I being for int, allows you to generate random integers on a closed interval from imin to imax, which includes the endpoints. So this is the syntax. You use rand I, and then we have the parentheses. Okay, so remember you do type those, and rand I being a keyword, you must type exactly that. And then we're going to fill in your desired integer minimum and integer maximum. So here are some examples shown over here. So this is going to operate on the interval of 3 to 6. This is going to, and we see that we're getting out a couple of different values, and you see that they are distributed on that interval. Type ranges. So because the amount of disk space allocated to specific types is specified, that's one of the points of doing that, there are going to be some limits on the numbers that can be stored in the type. So getting back to those uint8, right? So that has 2 to the 8th bits to be able to store integers ranging from 2 to 255, because 256 is going to need more disk space than is allowed by the type. So the reason is because the size of the integer is going to determine how many bits you need to use. Now, the notation here is, right, so when you have uint8, that means it's going to be 2 to the 8th power. We're basically always working in binary, so we're always thinking about specifying the power to which it's raised. This is why I made the point earlier that it doesn't mean that we can only store integers up to the number 8. What it means is we can store things that take up to that amount of disk space, that many bits to the 8th, which happens to work out to be 255 because it's 256 bits, but 0 is also included, so we get from 0 to 255. So as long as the integer that you need isn't going to exceed 255, then you can go ahead and use the smallest one. This is really useful because it will optimize your disk space. However, if you're having an integer and you think you might need to go above 255, then you need to pick a different type that has a bigger storage space. So probably 32-bit or something even bigger. So you can work out what it's going to be because you can just raise 2 to the power, but in case you didn't happen to remember what those are or whatever, you can just use MATLAB to tell you the max and min available using the respective min and max functions. So here is an example. You can do int min and int max. And so here is some examples as to what numbers you can store inside which variable type. Also, I would just like to remind you that you have all of this help documentation available if you should need further information. So if you want to get more info on how to use a function, you would just use the help command and then you would give the name of the function. So you can get that on int, max, min, all of these different things that we've been discussing. And so you can use help and then the name of the function that you're interested in. You can also get more additional information using the documentation command. So you use doc and the name. So to search for a function by specifying keywords, you could do doc and then you go to the search tab. And so then you could, for example, look for hyperbolic. So this is a one-word description of what you're looking for. All right, so that brings us to the conclusion of chapter 1. So we've talked about an overview of the course and how we're going to deal with this unique situation of moving to online learning in a bit of an unexpected way. Hopefully that's going to work out fine for you. And again, please do contact me if you should have any concerns about how we're going to do that or how it might play out for your particular situation. We had a first view of MATLAB, so we've gotten familiar with the various windows that are available, how to launch, how to get it, and how to move around in the environment. We also talked about variables and variable assignment. So how can you do this? We had some numerical and text-based examples as well as Booleans and looking at types and how to interconvert those. We looked at formatting. We have long versus short and loose versus compact and the ellipsis for continuing a line. Furthermore, we've talked about operators and functions, which work in really similar ways. Operators and functions are different things that are available in MATLAB. Many are built in and can be incredibly helpful. We also looked at some of the other things that MATLAB features, that is some constants and the ability to generate random numbers. So we looked at some built-in constants. There are, of course, many more, but we've introduced you to a couple of familiar ones, such as pi, and also using the scientific notation. We also talked about how to generate random numbers and how you can adjust the range to a range that's desirable to you. All right, so thank you so much for joining me for our first lecture in MATLAB. I look forward to working with you again and definitely would like you to reach out should you have any questions or comments. Oh, and just before we go, I do want to just flip through what you need to do in the upcoming week. So, and then looking ahead, you can see what we're going to be doing over the next week. So the thing you need to be doing is you need to be working the practice problems throughout chapter 1 for your lab. Please post those answers by Wednesday at 10 p.m. So that would be when you would have completed your lab. Also, for your homework, please complete any 10 problems from the chapter 1 exercises and post to Moodle. This is in your MATLAB. Please complete this preferably by 9 a.m. the following week, which is when I will be grading your homework so I can get your grades back to you. Feel free to visit me on the online Zoom meetings, either in our regularly scheduled class time or any of the office hours. And of course, you can also stop by during the other classes, but of course, they'll get preference. All right, thanks so much. We look forward to seeing you online and enjoy learning about MATLAB. Thanks very much and bye-bye. Bye-bye.